Good day. Today we are looking at linear programming. Linear programming. Now, linear programming is an optimization process. Now, when you see the word optimization is standing for two things, which are cost minimization and profit maximization. So when you hear the word optimization, what should come to your mind is that an organization wants to minimize cost or maximize profit. They can't do the two at the same time. It is either you are working towards reducing the cost of production, or you are working towards making more profit as an organization. And so we said linear programming is an optimization process used by organization for efficient use of resources. Organizations always have resources, and then so they are thinking of how will they manage the resources to be able to achieve the goal of the organization. Of course, what are the resources available to every organization? There are 5 resources that are always available to every organization. I call them 5 M's of management. You have man, you have money, you have material, you have method, and then you have machines. So these are the 5 resources available to every organization. Man is also known as human resources. The money is also known as financial resources. The material is also known as material resources. And so methods and machine. So all of these resources, an organization will always be thinking of how to use them efficiently. And then when they are now working towards efficient use of these resources by working towards reducing costs or trying to make more profit. You see, in every business, you must have a goal at every given point. Are you trying to cut down the cost of production, or are you trying to make more money? Because there are some businesses you can make more profit. What you can do is to cost of production. For example, people into pure water business. You know, you can't sell one pure water for more than 10 naira. And so what we work towards is to reduce cost. But you know, there are some businesses that you can make more profit. Maybe business of gold. You can decide to say, oh, let me just add more money. But why? It's a luxury good. So every organization will always be working towards reducing cost or making more profit. So when you are now using so linear programming is now a tool that you can use to achieve that. Okay, having said that, we have the properties of linear programming. Properties of linear programming. Number 1, we have objective function. Number 2, we have constraints. Number 3, we have finiteness. Number 4, we have additivity. Number 5, we have non-negativity constraint. Now, look at this. When you say objective function, what do you mean? When you say objective function, objective function means that at every given point, organization will always have the objective they want to achieve. At every given point, organization will always have the objective they want to achieve. and that objective can only be two. It can either be to minimize cost or to maximize profit. So objective function is telling us about what is the organization working towards at any given point. Are they working towards reducing cost of production, or are they working towards making more profits? That's what objective function is. Okay, objective function is that function that an organization is trying to pursue at a given point in time, which will either be to reduce cost or to maximize profit. That's what objective function is. Okay, number two is constraint. So number two is constraint. Now, constraints are like the challenges that the organization have in trying to achieve their objective function. Don't forget that organizations always have issues they have to battle with. At times they don't have all the money that is needed. At times the staff are not available. At times they don't have enough material resources. So the challenges that the organizations have when they are trying to achieve their objective function is what is called what? Constraint. So constraints are the challenges faced by organization in the course of trying to achieve their objective function. And the constraint will either be no enough financial resources, no enough material resources, no enough manpower, and things like that. In a country like Nigeria, a lot of organizations have the challenge of power, electricity. That's a constraint. So at times, maybe if they have enough power, they will be able to make more profit. But because power is always an issue, part of their profit, they have to use it to buy fuel or diesel to power their gen. So it will not make them to achieve their goal very well. So that power, that lack of electricity is a constraint. Number three, you have what we call finiteness. Finiteness. Now, finiteness is talking about at every given point, the resources that organizations have will always be countable. There is no organization that will have uncountable resources. Because if you have uncountable resources, there is no need for you to optimize. So most of the time, if an organization have money, they can value, they know the amount. If they have staff, they know the number of staff they have. If they have material resources, they know the number of resources they have. So finiteness is talking about at every given point, organization can count the resources that is available to them. Organization can say, okay, what are the resources that we have? We have generator, we have car, we have building, we have AC. So ability of an organization to be able to count the resources they have at any given point while they are running the business is what we call finiteness. Okay. Number four, additivity. Additivity. Now, additivity is saying that all the variables that organizations have, they are always added together to achieve one goal. Let me break it down. In an organization, you can have a gate man, you have a secretary, you have a manager, then you have the MD. All of them are working together to achieve one goal of the organization. So in every organization, whether you see the secretary or the gate man, everybody is working together to achieve one goal. Nobody is doing something on his own. So the gate man must be there to perform his own duty. The secretary must be there to perform her own duty. The MD must be there. The marketers must be there. The sales managers must be there. The general manager must be there. But all of them are working together so that that organization can succeed. That's what it's saying. So additivity is talking about the fact that variables within the organization are always added up to achieve one goal. which is the goal of the organization, and that goal could either be to reduce cost or to do what? Maximize profit. Okay, and lastly, you have non-negativity constraint. Now, non-negativity constraint is saying that resources available to the organization can never be negative. It can only be 0 or more than 0. Resources available to the organization can never be negative. It can either be 0 or more than 0. Let me explain that in a layman's language. If you call a place an organization, if they don't have gate man, they don't have a secretary, at least they will have a building. At least they will have offices there for you to call it organization. So there is no organization that will not have any resources. For it to be called an organization, they must have, no matter how little, they must have some resources. It's just like you going to a place and they call that place a school. If they call it a school, they may not have a gate man, they may not have teachers, but at least they will have classroom, they will have chairs in the class. Then you can now say this is a school. So organization at every given point will always have resources, no matter how little. It may not be enough, but they will have. They can't have 0 resources. They can't have negative resources. And that's what non-negativity constraint is saying. Every organization will always have 1 resources to work with at any given point in time. Okay, so the next thing we are now going to look at is what are the methods that you can use to solve linear programming. Okay, now we are looking at methods of solving linear programming. We have the graphical method and the simplex method. When you say graphical method, of course, this is when you use a kind of graphical illustration to illustrate how resources can be optimized in an organization. Now, it is very important for you to know that when you see less than or equal to, this is less than or equal to, less than or equal to. That's the meaning of this sign. When you see less than or equal to, it shows that you are maximizing. It shows that you are maximizing profit. And then when you see greater than or equal to, it shows that you are minimizing cost. So in linear programming, at times they will not tell you whether you are maximizing profit or you are minimizing cost. It is the sign that will make you to know what you are doing, the sign given in the question. So when the sign given in the question is less than or equal to, it shows that you are maximizing profit. You are working towards maximization of profit. But if the sign is greater than or equal to, which is this, it shows that that organization is trying to minimize cost. So please don't forget the sign. It's very important. At times, the question will not tell you maximize profit or minimize cost. Only the sign will tell you that, okay, this is what I want to achieve. Now, let's start with the graphical method and then just take an example. Now, let's say you are given objective function 4x plus 5y subject to 2x plus 5y less than or equal to 10. 3x plus 4y less than or equal to 12. And you have non-negativity constraint. X comma y is greater than or equal to 0. Now, if they want to give you a question will just come this way. Now, how will you know that the question is linear programming? Because here, they did not even say anything. They just wrote some figure. And then, you will now be like, what am I expected to do? Now, the moment you see objective function, and then you see subject to, you already know that, and you see non-negativity constraint, you already know that it's linear programming. Okay? Then number 2 is that, how will I know? Am I minimizing cost or maximizing profit in this question? Now, what will always help you to determine that is the subject to. You will check the sign in the subject to. Now, checking the subject to here, the sign that I have is less than or equal to, as you can see. Less than or equal to. You can see it. So, once you see less than or equal to, what does it show that you are doing? Maximizing profit. Now, I said, how will you know if you are to maximize profit or minimize cost in a question? How you will know is the sign that is given to you in subject to. Why did I have to mention subject to? Because non-negativity constraint, you will always have greater than or equal to 0. You don't need that one for anything. It's just an information that they are trying to give you. You don't need it to solve anything. So, you always need the sign in the subject to. So, the sign that you have there is less than or equal to. And once I have less than or equal to, less than or equal to, like I told you, is for what? Maximization of profit. So, it shows that in this question, I want to maximize profit. That's the meaning. Okay, so let's start the solution to this question now. Okay, so anytime you want to start, you always start from the subject to. The subject to is the constraint. The subject to is the constraint. Okay, this is the question we are given, and of course we want to solve. So when you want to solve, always start from the constraint. Pick the first equation in constraint, always. So you have 2x plus 5y is equal to 10. So at this point you have to change that sign to equal to sign when you are solving. Why this sign has to be there is so that it can tell you whether you want to minimize cost or maximize profit. And we already know that we want to maximize profit with this sign. So we pick the first equation, 2x plus 5y equals to 10. So I will now say, let x be equal to 0. Always start with that. Let this x be equal to 0. So I'm going to have 2 into bracket 0 plus 5y equals 10. So 5y, 2 times 0 is 0. So that's gone. So 5y equals 10. So to get your y, divide both sides by 5. So if 5 cancel 5, y is equal to 10 divided by 5, 2. So it shows that when x is 0, y is what? 2. When x is 0, y is 2. You see that? The same equation, let y be equal to 0. So if I rewrite that same equation here for explanation's sake, 5y equals 10, and I say let y be equal to 0. So that is anywhere I see y, I put 0 there. So 2x plus 5 into bracket 0 equals 10. So I'm going to have 2x plus 5 times 0 is 0. So it's gone. Equals 10. 5 times 0 is 0. So it's gone. It's no more there. equals 10. So I can now say divide both sides by 2. So 2 cancel 2, bring down the x. X equals to 10 divided by 2, 5. So it means when x is 5, y is equal to what? To 0. You see that? For the first equation, first make x to be 0, get y. Then make y to be 0, get x. That's the first thing. The second thing, take the second equation. Now the second equation is 3x plus 4y equals 12. I told you change that sign to equal to sign. So let x be equal to 0. What are you going to have? 3 into bracket 0 plus 4y equals 12. That is where I see x, I put 0. 3 times 0 is 0, so it's gone. 4y equals 12. Divide both sides by 4. Y is equal to what? 3. So it means when x is 0, y is what? 3. The same equation, 3x plus 4y equals 12. So I can say let y be equal to 0. So I will say 3x plus 4 into bracket 0 equals 12. That is where I see why I put 0. So that will now be 3x equals 12. Why? Because 4 times 0 is 0, so it's gone. So to get my x now, divide both sides by 3. So 3 cancel 3. X equals 12 divided by 3, that's what? 4. So when x is 4, y is equal to what? 0. So you see that? So with this now, we are now going to plot our graph. Now if you are not clear, you can play the video again and then you have the understanding. Okay, the first equation gave us these two brackets and the second equation gave us these two brackets. So that's what we're going to use to plot our graph. Now if I do my graph like this, now you can see that. Now this place is always my y-axis and this place is always my x-axis. So using the first bracket, the first two brackets to plot my graph, x is 5 when y is 2. So I can just pick a point here, call it 2, and then pick another point here, call it 5. You see that? Why did I pick a point here and call it 2? Because y is 2. Why did I pick a point here and call it 5? Because x is 5 from this first bracket. So I can now, use my ruler to join these together. So I can label the graph. The equation that gave me that was 2x plus 5y equals 10. That's the equation that gave me this line, these two brackets that form this curve. Then the second bracket, y is 3, x is 4. You see that? Look at me, don't write. Y is 3, x is 4. So pick a point. Since y is 3, pick a point here. Why? Because 3 is on top of 2. The graph is starting from 0 up like this. So 3 is always above 2. Then x is 4. 4 is below 5. So let me just pick a point here and call it 4. You see that? Our x is 4. So I pick a point on the x-axis and call it 4. And because 4 is before 5, that's why I put it here. Then y is 3. I pick a point here and call it 3. But y is above, 3 is above 2. So I have to pick a point above 2. So now I'm joining these two together also. You see that? So the equation that forms this line is 3x plus 4y equals 12. So do you see this now? Now there is something I quickly need to explain. How do you get your required region or visible region in a graph of linear programming? Required or visible region. Now, if you have a graph like this, and the sign that you have in the question is less than or equal to, that shows you are maximizing profit. Don't forget, when you have less than or equal to, it shows you are maximizing. How will you shade? How will you know the shaded portion? Anytime you have less than or equal to, you will always pick the lowest corner point. That is this point, and then this point. Because what you have is less than or equal to. But let's assume that you have a graph like this, and what you have is greater than or equal to. How do you get your corner point? You pick the outer points, which is this, and this. So this will be your shaded portion. This will be your required or visible region. So the sign that you have determines where you will shade. If it is less than or equal to, see the way you will pick it. But if it is greater than or equal to, see the way you pick it. You pick the outer point. If, for example, you have something like this, and then you have less than or equal to, how will you know where to shade the inner point? See how you pick it. Here, 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 and here. You always go for the inner point. So these places that I shaded are the required region. You see that? But let's assume that you have something like this, and it is greater than or equal to, you are picking the outer point here, let's say this is what I have, and then you have this. So you are picking the outer point here, 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 and here. You will assume like this straight line is not there. So you are picking outer point. You see that? The points that are outside, that's what you are picking. But if it is less than or equal to, you are picking the inner point. So I need to explain that. So with that now, you know in this question, what we have is less than or equal to. So my corner point will be here, here, and here. So I will shade this place. This is my what? Required region. So I can label the point and say this is point A, point B, and then point C. You see that all those places where I put dot. For example, if I want to label it here, A, B, C, here A, B, C, here A, B, C, D, here A, B, C, D. That's how you label the point. So now that I've labeled the point, at this my point A, what's the value of x? The value of x is 0, and the value of y is 2. How do I know that? You know this is y-axis, and this place is point 2, and that point 2 is on y-axis. So y is 2, and then x is 0 at that point. At this other point here, how will I know what is in point C? My x at this point is 4. Why? Because on that point I have 4 there, and it's on the x-axis. Then y is 0 at that point, because this is point 0. So at this point C, x is 4 because it's on x-axis, y is 0. At this point A, y is 2 because 2 is on the y-axis and x is 0. So the one remaining for us is what? Point B. How do we now get x and y in point B? So for us to get x and y in point B, we have to do simultaneous equation. Why? Because two lines, this equation and this equation, they are meeting at that point. So we'll use the two equations to get the value of x and y for this meeting point. Okay, so let's do that. So we can now say that bring the two equations to do simultaneous equation. So the first equation is 2x plus 5y equals 10. The second equation is 3x plus 4y equals 12. So you want to use this as simultaneous equation to get x and y. Now when you want to solve a simultaneous equation, always use elimination method. It's about the simplest. There are so many methods you can use. You can even use matrix to solve it, but you don't need all of that. So how do you use elimination method? Pick whatever number you have here, bring it up and use it to multiply everything. Whatever number you have as coefficient of x, bring it down and use it to multiply everything. So it means if I have 5 here, I have 7 here, bring 7 up, bring 5 down. Any number you have there at top, the one up, bring it down, the one down, bring it up, always. So if I say 3 times 2x, that will give me 6x. 3 times 5y, that will give me 15y. 3 times 10, that will give me 30. Then 2 times 3x, that will give me 6x. 2 times 4y, that will give me 8y. Then 2 times 12, that will give me 24. You see that? Now that you have gotten this, you subtract. So subtract the equation. Now if you like, you want to label the equation and say equation 1, equation 2, equation 3, equation 4. But I don't need all of that. Now subtract here means I want to subtract this equation. So 6x minus 6x, it will cancel out. 15y minus 8y, that will give me 7y. Then 30 minus 24, that will give me 6. So to get my y, divide both sides by 7. 7 cancels 7, y equals to 0.6 divided by 7 should be 825. Am I right? 0.6 divided by 7.
86. 2.86.
Okay. So now that is my y. Then I will now try to get my x. I will say put in the value of y in equation 1. 2x plus 5y. Okay, now this corner point, I brought it from the graph. I expected you to reverse the video, write it down so that you'll be able to know where I picked the figures from. They are from the graph. So these are corner point A, corner point B, and corner point C. We are now using it with the objective function. So coming here now, I'm going to say that, okay, our corner points, our corner point A is 0 and 2 for x and y. Our corner point B is what? 2.85 and 0.86. Our corner point C is 4 and what? 0. So I will write the objective function 4x plus 5y. They gave me this at the beginning of the question, so I'll bring it here. So I can now write 4, open the bracket, write the 4 across, plus write the 5 across too. Because the 4 and 5, they are constant in the objective function. So the x and y, which are the brackets, will now be putting these values there. Look at me, look at me. So here now you put 0 and 2. 0, 2. This 0 and 2. Here now you put 2.85, 0.86. Then here you put 4 and 0. All these values, you put them in the bracket. The 4 and the 5, they are not changing. So now let's try to get the answer. Here now, 4 times 0 is 0. 5 times 2 is 10. 10 plus 0 is 10. Then here, 4 times 4 is 16. 5 times 0 is 0. 16 plus 0 is what? 16. So I need to get this. Who will give me the value for this? 4 times 2.85. 4 times 2.85.
11.4.
Plus 5 times 0.86. 5 times 0.4.3. So if I add that together, that will give me 15.7, I guess.
Yes.
Okay. So here now, you will now look for the highest value. Why are you looking for highest value? Because you are maximizing profit. If it is that you are minimizing cost, it's the same process you will follow, but by the time you get to this point, you will pick the lowest value. But if you are maximizing profit like we are doing, you will pick the highest value. So here now, what is our highest value? 16. So it shows that that organization, for them to maximize profit, so I can say for the organization to maximize profit, four of X and 0 of Y should be used. That is, for that organization to maximize profit, they have to use 4 units of X and 0 units of Y. You stop, Abby. So now, for you to now know because we are picking 16 as the highest, we will now look at the value of X and Y at that point. X at that point is 4, Y at that point is 0. So for the organization to maximize profit, they have to use 4 units of X and 0 units of Y. So 4 units of X and 0 units of Y should be what? Should be used. So that is the end of the solution. So this is how to do linear programming using graphical method. I'm going to send some questions on linear programming. I expect you to solve them and then get back to me.